Hi friends, in this video we are going to discuss about the differences between synchronous machine and asynchronous machine. Generally, rotating AC machines are two types. Generally, the rotating AC machines are two types. What are those? The rotating AC machines are generally two types. Those are, one is synchronous machine and another one is asynchronous machine. Synchronous machine and asynchronous machine. Right. Now first tell me, what is the meaning of synchronous? Synchronous, what is exactly meaning? General meaning, what is general meaning? The general meaning of synchronous nothing but gets together. Together. They are doing something together. Together nothing but synchronous. I sync with my friend, which I doing the same as him. Nothing but we are getting together, same, doing same. Nothing but synchronous. Right, now tell me why it is called a synchronous machine, why it is called as asynchronous machine. Why it is called a synchronous machine? Generally in our AC machine, in our AC rotating machine, we have two parts. One is the stator, another one is the rotor. Generally, if it is motor, it is given by three-phase AC supply. If it is generator, it develops the three-phase AC supply. Whatever it may be, in stator we have a three-phase AC supply. If it is motor, it is given by three-phase AC supply. If it is generator, it produces the three-phase AC supply. Whatever, the stator carries three-phase AC supply. When three-phase AC supply developed in the stator, when three-phase AC supply developed in the stator, then automatically, by immediately, the rotating magnetic field will be produced. Sir, we know that is the magnetic field, but I don't know exactly it is rotating magnetic field or stationary magnetic field. I will give you proof about this just 10 minutes later. I will give you proof. It is a rotating magnetic field. Okay, so the rotating magnetic field produces in the stator winding. That stator winding produces rotating magnetic field which rotates in clockwise direction with synchronous speed. Which rotating here? There is no rotation of stator. Listen carefully. There is no rotation of stator. Stator is the stationary part. That stationary part contains some winding. It's called a stator winding. That stator winding given by three-phase AC supply. When three-phase AC supply given to that stator winding, that winding produces a magnetic field. That magnetic field is called as rotating magnetic field because it rotates in clockwise direction with synchronous speed. Yes, now the magnetic field is rotating in one direction, in clockwise direction with synchronous speed. If our rotor also rotates in the same direction with same speed, these two fellows. Who are they? One fellow is the rotor and another fellow the stator magnetic field. The rotor and stator magnetic field doing the same, then it is called as synchronous. If they are not doing the same, they are called as asynchronous. So, if my rotor also rotates with same speed in same direction, nothing but the rotor speed Nr is equals to Ns. If the rotor also rotates in the same direction with same speed, if Nr is equals to Ns, that machine is called a synchronous machine. That machine is called a synchronous machine. If Nr is not equals to Ns, if Nr is not equals to Ns, nothing but the rotor is not exactly rotates with the speed of the stator field. That's why if Nr not is equals to Ns, that machine is called as asynchronous machine. That asynchronous machine generally we are called as induction machine. That asynchronous machine generally we are called as induction machine. Now okay, we have a clarity. What is synchronous machine and what is induction machine? If Nr is exactly equals to Ns, synchronous. If Nr not exactly Ns, asynchronous. Right, sir. Let's see. Generally, every machine having two modes of operation. What are those? One is the generating mode, another one is the motor mode or motoring mode. The synchronous generator is also called as alternator. Synchronous generator is also called as alternator. So here in synchronous machine we have two modes. One is the alternator, another one is the synchronous motor. Whereas in our induction machine also we have two modes of operation. One is the induction generator, another one is the induction motor. Induction generator and induction motor. Yes. Now in synchronous generator, NR is exactly equals to NS. In synchronous motor, NR is exactly equals to NS. Whereas in induction generator, we know, sir, NR not equals to NS. I know that. But what is the NR? Not equals to NS, of course. Is greater than NS or less than NS? If it is less than NS, nothing but not equals to NS. If it is greater than NS, nothing but not equals to NS. Now tell me in induction generator, what is my rotor speed? In induction generator, my rotor speed is greater than synchronous speed. Very important. In induction generator, my rotor speed is greater than synchronous speed. Nothing but not equals to synchronous speed. Now you can tell what is the speed in induction motor. In induction motor, the speed is less than synchronous speed. Here less than synchronous speed, and here greater than synchronous speed, and here equals to synchronous speed. Yes. Now you can say that which of the following generator is constant speed? Synchronous generator is constant speed. Synchronous motor also constant speed, but these are not constant speeds. Okay. Very important. What are the applications of synchronous generator? Can you tell me? Tell me first. What are the applications of synchronous generators? Nothing but alternators. Yes, nowadays in every power system generating stations, we have alternators only. Yes or no? Wherever you go, for example, hydro power plants. In hydro power plants, the turbines are connected to a generator, which is called as alternator. Thermal power plants, nuclear power plants, like such a power stations to develop the energy, to generate the power. Generally, we are using alternators. Hydro power plants, thermal power plants, and nuclear power plants, the best examples for applications of the alternator. The best examples for applications of the alternator. Now, can you tell me what are the applications of induction generator? Can you tell me? These are also used to develop the energy. Nothing but used to produce the energy, power. But where? Where? Generally, these are used in wind power plants as well as tidal power plants. Sir, why we are not using alternators here? In wind power plants also, if we are using alternators, what happens, sir? Sir, already you told that alternators are used for constant speed. Is the wind speed is constant? Is the tide's speed is constant? Never. The wind speed is not at most constant. Not it is constant. That's why these are generally in these power plants, we are using induction generators. We are using induction generators. Right. And next one. Generally in alternators, whereas in synchronous machine, the rotor frequency is exactly equals to stator frequency. Rotor frequency is exactly equals to stator frequency. But whereas in our induction machine, you already know that the rotor frequency is equals to S into Fs. Slip times of the stator frequency. Slip times of the stator frequency. Now they are asking question. In both the generators, induction generator and synchronous generator, which is directly connected to the power grid, which is directly connected to the power grid. The synchronous generators are directly connected to the power grids, whereas our induction generators are connected to the power grids through the frequency converters. These induction generators are connected to the power grids through the frequency converters. Those are not directly connected to the power grids. These are the main differences between the synchronous machine and asynchronous machine. Right? Up to now, we saw that the differences between transformer and induction machine, and the differences between synchronous machine and induction machine. After completion of all these, they are asking very silly questions. Now tell me the answer. Tell me the answer. For same rating of the transformer and induction machine, for same rating of the transformer and induction machine, which machine having highest efficiency? Which machine having high efficiency? Transformer and induction machine. Compared to those two, which machine having high efficiency for same rating? Can you tell me the answer? As exactly transformer having the higher efficiency than induction machine for same rating. Sir, why? Why? The friction and windage losses are not less is equals to 0 for transformer. The friction and windage losses are 0 for transformer, but these are not 0 for rotating machines like an induction machine. These are not 0 for our induction machine. That's why the friction and windage losses are there in our induction machine, but there is no friction and windage losses for transformer. That's why now tell me, the losses are more in induction machine. The efficiency is high for transformer. Efficiency high for transformer. These are the main differences between these machines. Right. That's it.